the topic actually is about generation. And just before I start, I think it's worth flagging that marine renewables, and by that I mean wave and tidal technologies, are not yet actually generating any power on a commercial scale anywhere in the world. So really, we're talking about a potential industry developing. The Carbon Trust in 2006 said that wave and tidal technologies could be supplying 3% of the UK's electricity supply by 2020. With subsidies, I think that can be equivalent to approximately £2 billion in annual revenues with renewable subsidies. Interesting, just going back and looking at the comment at the bottom of the slide, I mean, even 20, 25 years ago, people were talking about the potential for wave energy to actually power the world. That estimate of 1,000 gigawatts, I think, could be 10,000 gigawatts or 20,000 gigawatts. There's certainly enough power in waves around the world to, if converted, to generate very meaningful levels of power. The challenge is can it be actually done? There have been a number of projects around the world, particularly in the UK. I have to be quite honest and say the results to date of the performance testing have been quite poor. But that's probably a reflection of the fact that there are very significant challenges. Deploying offshore in hostile environments is undoubtedly difficult. But if you actually look at what the market really wants to do, certainly governments in the UK, the Scottish Executive, the Portuguese government, are looking to encourage the development of wave and tidal technologies. What do they want though? They ultimately want stuff that works, very much like the investors want stuff that works, and very much like the utilities want stuff that works. It's ultimately about proving that the technologies can work reliably and consistently and generate meaningful levels of power. And once you can get that little nut cracked, I think you then move on to the next stage, which is can you actually build a profitable business? Which really means, can you control the capital expenditure? Can you reliably predict operating expenditure? And ultimately, can you really model a commercially viable cost per kilowatt hour? Utilities have very comprehensive models to be able to do this. We've been in discussion with a number of them. I think the point is the industry has been at the development stage for some time. I think now the final comment on the slide is quite relevant. People in the current market, both government, utilities and investors, want to see performance data, and that's really what Trident Energy is trying to do at the moment. Very briefly, I'll just explain our system to you. What you see there is a schematic. It's a rig-based structure. The tall legs that you can see, probably about 2/3 of the structure is below the waterline. The floats in the middle that you see will be resting on the sea level, and the sea acts on the floats, raising the floats up and down and pushing them through permanent magnet generators. Our power takeoff is really where our IP resides. We have magnet stacks on the top level of the rig, and as the float moves up and down, it pushes the copper coil through the stack, resulting in immediate generation of electricity. But obviously, to prove the value of our technology, we've had to develop a system which we've broken down into 6 key components. We've worked with Cambridge University on item 2, which is the power conditioning. We've done some extensive research with them over the last 2 to 3 years. We've developed a rig structure with subcontractors based in Lowestoft, a small company, and also with the design consultancy from a regional marine architect. We've also had to look at mooring systems to actually deploy the technology, work out how to take the technology offshore and deploy it. That's been an undoubted challenge for us. I think the point here is that at least half, if not all of the components of our technology are already existing products. Our linear generators is a new component. Power conditioning already exists. Rigs and floats already exist, as do mooring systems and do offshore grid connections. So unlike some of the other marine technologies, we are trying to build a genuinely component-based solution that can leverage existing supply chains. So we've been going for a number of years, approaching 5 years now, and we've actually, the first 2 to 3 years were really focused on a controlled R&D program in conjunction with Cambridge University and also working with the New and Renewable Energy Centre in Blyth, Northumberland. We've done 3 major wave tank tests up there. We wanted to simplify the design so that we could genuinely show that the system could be replicated quite fast. It's taken us actually quite a bit of time to do that, but we do believe we've got a very simple design and an easy to understand component-based modular architecture. I think, coming back to my earlier point about needing to prove the worth of the technology, we are now focusing on deploying a rig during the summer view. Hopefully this summer. Hopefully end of July, middle of August, I think is around about the time frame we're looking at the moment. But the main purpose of this project is to actually test the performance of the technology and obtain real verifiable performance data that we can share with interested parties later this year. And that will enable us to build a partnership framework to enable further rollout of the technology. Just to put a few photographs in just to show, this just shows some of the earlier testing that we've done at Narek, which is in Northumberland. We've done some extensive wave tank tests there. The first test was really focused on could we get the generator to work reliably, and we did. The second testing was actually could we get the generator to work in hostile environments. You see that there is a difference in the size of the wave there. We had the largest waves in the Narek tank running down the wave flume. And the third test was could we actually deploy a rig in it? So it's kind of dropped the scale of the device, but could we deploy a rig and test the stability of the rig and run multiple point absorbers with floats to see if we could generate electricity from multiple generators, which we also did as well. The challenge then is to take that R&D experience and to move the technology offshore. We are fortunate to have the founder of the company who has a 30-year track record in designing and building linear motors and generators. So, rather ironically, one of the easier parts of the project for us is to actually be able to build a linear generator. It's quite a novel design, and we have got a number of patents registered on that particular generator. But what we then worked with Cambridge is to condition variable AC into grid-compatible AC. I worked with design engineers to build the right kind of rig structure, which you can see there, which is on the dockside in Rostov, which will be floated out and actually pulled down to the seabed. And in our experimentation, we've also worked out that conventional spherical floats actually don't give you the maximum power output from a wave. We've got a special float design that actually improves the performance of the generators. And probably, finally, the biggest challenge really for us is the mooring system. The more work we've done on the project, the more we've realised that moving offshore, you really do need to work with experts. We've actually appointed a specialist mooring company with proven experience in the oil and gas industry, and I think that's one of the challenges that we underestimated earlier on. I'm happy to admit that we've had to relook at it, and I think we've got a very effective system now. How do we really move from the R&D stage to the C-trial stage to the generation stage, which is really what this section is about, really getting renewable generation online? Well, the reality of the situation is that Trident Energy is a small company. We're in the SME sector. We're funded with private equity investment. We're funded with grant support, both initially from the Carbon Trust and more recently from EDA. And we have to be quite sensible about this. We really need to start playing with the big boys. So the strategy is to use our demonstration system to develop credible data. We can build a credible argument that the fact a bigger rig with more floats and more generators would generate more power. But really we need to form a consortium, and I think that this would be with utility support, possibly larger scale marine engineering support, and maybe some government support by various government schemes that exist, to actually develop the technology to the next stage and maybe produce a multi-megawatt system. That's the challenge for the wave sector as a whole. There's been sporadic, small-scale, unreliable generation. We're hoping that our offshore test system this summer will enable us to prove we've got a reliable way of generating and converting seawave energy directly into electricity. And we're looking to extend relationships with utilities and bigger partners. What does it mean? I'm not quite... Ultimately, our rig is on the left in the photograph with some artist impressions of what a bigger rig. In reality, we probably wouldn't go that big. We'd have multiple units of maybe 1 or 2 megawatts per unit. But really, the challenge for small companies, big companies and investors is to work together to actually bring emerging technologies that look credible to market. And certainly Trident Energy thinks it's got a breakthrough technology in the sector, and we're hoping to be talking very constructively